Alright, so welcome to the ninth problem. This problem is going to be about isotopes. So before anything, let's recall what isotopes are. Isotopes are samples of an element with different numbers of neutrons in their atoms. This change in the number of neutrons causes the molecular masses of the isotopes of an element to be different. But the number of protons is never changing. It's always the number of neutrons that changes, and that causes that change in the molecular mass of the isotopes of the element. So here we have the problem. And the problem says the following. Strontium exists as 4 naturally occurring isotopes. Calculate the relative atomic mass of strontium to 2 decimal places from the following data. So as we can see, we have 4 isotopes of strontium with different molecular masses. So there's an atom of strontium with a molecular mass of 84, of 86, of 87, and of 88. Now, all of these 4 isotopes exist in nature, and their relative abundance is how common they are in nature, right? So the strontium-88 is the most common one, as we can see. It 82.54% of the time that an atom of strontium is found, it is this isotope, strontium-88. And the rest is the same. So next it would be strontium-86, and then strontium-87, then strontium-84. However, it's all these 4 that are present in nature, and with their relative abundances that add up to 100 always, we're able to determine the relative atomic mass of strontium by itself. So let's go ahead and solve this problem. So the way to solve it is to first find the total mass of 100 atoms. Now, we know that all the percentages are going to add to 100%. So we take the molecular mass of that isotope and we multiply it times its percentage to have its relative mass, right? And we're going to do that for all the 4 isotopes, and then we're going to add them together to find the total mass of 100 atoms of strontium that can be just randomly found in nature. So I go ahead and take that molecular mass of strontium-84, which is 84, and then multiply it by 0.56. And then go ahead and take that 86, multiply it times 9.9. Go ahead and take that 87, multiply it times 7. And go ahead and multiply that 88 by 82.54. We do all of that, we get that total mass of 100 atoms is equal to the quantity of 47.04 plus 851.4 plus 609 plus 7,263.52. If we sum all that, we get that the total mass of 100 atoms is 8,770.96. Now we need to divide all of this by 100 because we have multiplied the molecular masses times the percentages. And now we need to transform that into decimal. So if we wanted to go directly about this, we could just beforehand divide each of the percentages by 100 before multiplying them by the molecular mass. However, I think this method is easier. You just multiply the molecular mass times the percentage, add them all together, and when you already have that total mass of the 100 atoms, you divide it by 100 to get to the actual relative abundance. So we do that. We take that total mass of 100 atoms that we found, we divide it by 100, and we get that the relative atomic mass of strontium is 87.7096, but the exercise says to 2 decimal places, so that just rounds up to 87.71. Now, if you were to repeat this exercise with any other isotope, you need to take the molecular mass and multiply times the percentage of all the isotopes. There's elements that have 4 isotopes, or 5, or 3, or 6. So you need to find the total mass of the 100 atoms. So you need to take into account all the isotopes that are given to you. So yeah, that would be it for this problem. I hope you learned about isotopes and how to solve for relative abundance given data table. And again, the presentation is linked in the description. And thank you.